So solving logs and exponential using either the table or the graph feature on a calculator. So this first problem we're going to talk about a red car and a blue car. So the red car, I'm going to give you some information about it. It's worth 20,000 when you get it. It depreciates. Oops, I think I just spelled that wrong. Depreciates 8% per year. And then the blue car is going to be worth 16,000, but it's only going to depreciate by 7% per year. We want to find out when are the two cars' values equal. So how long do I have to keep either my red car or my blue car for them to be worth the same amount? So remember, this is exponential because it's talking about a percentage rate of how much you have to, how much it's losing on its value. So for the red car, we have to remember that if it's depreciating, it's losing value. So you have to say 100% minus 8%. So 100 minus 8 would be 92%. So your multiplier on this in this case is going to be 0.92. So you got to move the decimal twice. This one you're going to do the same thing, but it's 100% minus the 7% because that's how much it's depreciating. 100 minus 7 is 93%, which when you write it as a decimal, it'd be 0.93. So the equation for the red car, remember for exponential you always have to have the starting value, so 20,000 times 0.92 to the x. And we're looking for when it is equal to the blue car, which the blue car's equation is 16,000 times 0.93 to the x. So we're going to look when these two equations are equal to each other. So I'm going to type in my equation. Sorry, I already did it, but I'll clear it and do it again. So 20,000, 1, 2, 3, 4, times 0.92 raised to the x power, and then 16,000 times 0.93 raised to the x power. Now I'm going to hit graph. We know that it starts at 20,000 and 16,000, so you're not going to be able to really see it on the graph. Actually, I'm going to do table first. So second table, and I'm going to go down. Notice these aren't equal. Those are getting closer. 7,900, 7,200, 67, 62, 57, 53, 52, 50, 48, 46, 41, but we're getting really close. 37, 73, 37, 47, and then the next one is 34, 72, and 34, 85. So you know it's somewhere between 20 and 21. Now I'm going to hit graph, and of course we're not going to be able to see it. This little icon up here tells you that it's still thinking. You have to wait for that to go away before we can change our zoom on our calculator. Okay, so now that went away. So I'm going to hit zoom, which is right here, and I want to zoom out. So I'm going to go to 3, and I'm going to hit enter. Have to let it finish thinking again. Sorry, these calculators are slow sometimes. Okay, there you go. Now hit enter again. and it will zoom out again. Okay, now it's drawing the first one. And there's the second. So since we can see both of them, it looks like the red is then on top. So we probably are going to be able to see where they intersect. So hit second trace, go down to number 5, intersect. Remember where they're intersecting or where they're crossing each other? That's when they're equal. So that is where our solution is. So remember, hit second trace and then just hit enter, enter, enter until it actually gives you the intersection. So they are equal when x equals 20.64. So 20.64. Notice if you look at the y, that tells you what both of their value is. So both of their value after 20.64 years, because it's talking about per year, is $3,577. So it took quite a while for these two cars to be equal to each other, even though this one depreciated at a lower rate. Okay, so you can, I'm going to write out the steps that we took. So we hit zoom, and then we hit out, which is 3. I have had on occasion zoom fit will work. So I'm going to go back to the normal zoom window. So I'm going to hit zoom 6. That takes you back to the normal window. Of course, we're going to have to wait for it to load, so I'm going to keep writing. So we did second trace. We did 5, which was intersection. And then enter, enter, enter. And that's how we found x equals 20.64. Okay, you can also try zoom. And then if you keep going down, there's one that says zoom fit. And sometimes that will work. It's going to be really close. Let's see if it'll find the intersection. So hit second trace, go down to number 5. And it's thinking, okay, so it won't find it. So sometimes that one will work just depending on the type of equation you have. You could just zoom out once from there and it would find it. You can also look at the table. So second table, we looked and we knew it was between 20 and 21. There is a feature, if you look at the right above window, it says table set. So if you hit second window, when you do this, if you want to use the table, you're going to hit to find in table. You're going to hit second window. You're going to hit tables, or you want your table start to be the year they switched. So in our case, it would be 20. And then you want to hit that triangle TBL to be 0.1. So that triangle means delta, or how much it's changing by. You haven't seen that in a while. But so you're going to do 20. And I'm going to tell it, I want it to go by 0.1. So the table start tells it what value to start at. So I have students that like to mess with people, and they'll put the table start at like 2,000, and then the person has to scroll all the way back up. Or you could just hit this table set and set it to whatever number you want it to start at. And then the delta table is how much is each value going to change by. So I'm going to hit second table again. And notice it goes 20, 20.1, 20.2, 20.3, 20.4, 20.5, 20.6. And you want to look at when they're the closest. Well, 20.6 is the closest. This one's 8.9, that one's 8.8. Then this one, they're off by 3. So 20.6, and if you notice, if you round that, 4 rounds to just, or it goes down to 6. So 20.6 is the answer on that. So I don't care which way you do it. If you want to keep just zooming out, you notice that you have to have a lot of patience because you have to let it quit thinking. Or you could look at the table, figure out what year it switched, and then do delta table, or how much the table's changing by, and that's one way to do it. Some of your equations are a lot easier, so let's do another example where it's just an equation. So if I give you 5x plus 4 equals 12, again, it's two equations set equal to each other, so all you have to do is type the first one in y1 and the second one in y2. So we're going to do 5 raised to the x plus 4 and equals 12. Hit graph. Oh, I need to put my graph back to the normal window. I'm going to hit zoom 6 to go back to the normal viewing window. Okay, looks like I have to zoom out once. So this is why the graph gets irritating, because you have to zoom in, zoom out, change your window. But now I can see them crossing, so I can do second trace, 5, enter, enter, enter. And my answer is x equals negative 2 point, I'm going to just do one decimal this time, so 2.45. That 5 rounds the 4 up to a 5. So that would be my answer. Okay, you could do second table again, except for I need to change the table set. I'm going to change it to a negative 3, and then I'm going to go by 0.1. So second table. Notice we said 2.5. Yeah, those are the closest. That one's only, it's less than a point away. This one is more than a point away, so it would be negative 2.5. So I don't care, again, which way you do it, either using the zoom and intersection or the table.